Assembly level language is also called as an mid-level language program, which is not same as an high-level language program. So the firmware is a combination of hardware and software. So the application software is related to only one single task and system software is related to multitasking. Hello everyone, it is Dr. Ravi Kumar. Today we shall have the discussion of operating system softwares and operating systems. In this system software and operating systems, you will study the general idea of the system software. What is the meaning of system software? A software which interacts with the computer's hardware and acts as an intermediary between user and computer hardware is called a system software. Then, which is that system software by name called? An operating system. I can give you the example of a Windows operating system, or it may be an Android operating system, or it may also be a Linux operating system, or it may also be a Unix operating system, or maybe anything. These operating systems which serves as an intermediary between a computer hardware and the user are called as a system software. These system softwares plays a significant role in interaction between a user and the computer's hardware. How does the operating system knows that these are the tasks to be carried out by the system software as an interface between user and hardware? Whenever the user requests for a service, it receives the request and serves the requests of user in the form of a response. The response may be in the form of a process management, memory management, or disk scheduling. All these are some of the important tasks which needs to be managed by the system software. So that's why I'm calling this as a main significant job done by the system software. Here in this introduction part, you will see that there is first unit called Machine Architecture and Assembler. In this chapter, in this unit, Machine Architecture and Assembler is a topic of discussion that helps you to learn about the architecture of a system that has been designed inside your computer, and how those architectures have been incorporated with a system software. That means a system software is a software that has been incorporated into an architecture, together forms it to work with the system. I hope you are following well. Now, a machine architecture is developed by the hardware designers, whereas the system software is a software developed by system programmers. Bit configuration of a system and the operating system bit configuration, supported bit configuration, must fit together to work very well. So you will study that what is the architecture of a machine and how the assemblers designed by the system programmer works with the architecture of a system. In this unit 2, you will study about the macro language. A macro language is one that helps you to place these information in terms of the definition. Suppose if you have a declaration, you will place the definition in place of declaration. The same thing applies here. The macro language and macro processors are one and the same. That means they interdependent. A macroprocessor is again a system software that helps you to load the macro language into the system specific location. What does that mean? A loader. A loader is again a software. When you boot your system, when you press the power button of your system, automatically the operating system, I mean in general terms, a system software is loaded from ROM, that is read-only memory, to the main memory. If I say that, what is a loader? A loader is again a system software that is inbuilt with ROM, that is read-only memory. This ROM will help you to load the operating system at the first location of your RAM. If I say that a RAM, this is your RAM. Let me tell you that this is your RAM. This is your ROM. Now, when you press the power button of your system, these contents are loaded from here to the main memory. This is called as a main memory, also called as RAM, random access memory. Here, the loader helps you to load this operating system from here to here. Once it is loaded to the first instance of this, the operating system starts working in its own. That means it helps you to load many other programs, whether it may be a system software or another application software. So you must be careful with the use of these ROM and RAM. In this case, I am speaking about the loaders. Again, a loader is a software that loads the operating system from ROM to RAM. Once it is loaded successfully onto the RAM, the operating system will start working in its own, in coordination between user and the computer hardware. So you will study all those details in Unit 2. Next, in Unit 3, you will learn about process and how those processes can be managed. Then, what is the meaning of process? When the operating system starts executing the programs, the process is called as process. Please don't get confused with the terminology I am using here. It is the procedure followed by the operating system to serve the requests of the user. Here, who is the user? The person who wants to use the system is called as a user. Where is the hardware? Hardware is present inside the computer. Then, who is that person? Who is that software? Which is that software that is helping the users to load the softwares from specific part of a computer to the RAM, or from RAM to many other locations of a computer? So in this case, you shall see that the process is created. When the process is created, when the operating system is loaded successfully onto the RAM starts loading other programs requested by the user. That is called as a process. When the program is executed successfully, we say that the process completed successfully. That means a process is one which is created for the execution of a program. In the sense, you will see that how these processes are managed. Yes, of course, that comes into your mind. Then you will see that the management of process. How these processes are managed? Using the operating system software. How these processes are managed? Again, there is a question. We will use the data structure called process management table, which is the table that helps you to manage these processes. Let me clarify you that. Suppose if you have an assembly level language, you are going to use a table or a data structure table called optab. What is the meaning of optab? Opcode table, symtab, symbol table. Like this, a process is also managed in the process table. So this process management is carried out again by the operating system. Then scheduling and deadlocks is the fourth unit of operating system. Whether you take the operating system Android, or it may be a Linux, or it may be a Windows, or it may be a Unix, or any operating system, the process management is very, very important here. Because you know that once when the programs are loaded from one location to the another location, it has to be managed properly. If it is not managed properly, then it is very difficult to continue the execution of programs. So the process management is required. Who is going to manage that? Again, it is the responsibility of this operating system to manage the processes. During the process of management of processes, it has to schedule. That is, this process is to be executed at this time. This program is to be executed in this time. Third program is to be executed at this time based upon the request of user. That means these scheduling criteria is managed by the operating system. During this process, there is also a possibility of deadlock. I am using the new word called deadlock here. What is the meaning of deadlock? During the process management, there is also a possibility of conflicting. That is, when the program is being executed, another process may come into the picture and wants to execute the another program, but there is no space allotted to it. So in such cases, again there is a resolution. That means one process is waiting for another process, third process is waiting for second process, first process is waiting for third process. So there is a circular deadlock. In other words, you say that system is hung, system hang. You people may have used that word. That means the system is not working properly. So in order to manage and make it work properly, we need to have a deadlock management, a deadlock resolution. How that deadlock resolution is done by the operating system? That is, whether the system is in safe state or in deadlock state is going to be predicted and taken in the right direction. That is the responsibility of operating system. You will study all those details here in this subject. So into the introductory part of this system software, a computer processes digital data. You know that a digital data may be a 10, 20, 30, 40, or it may be any of the variables. A is equal to 10, B is equal to 20, C is equal to 30, or so on and so forth, or it may be anything. These data supplied by the user has to be managed properly. In order to manage all these data digitally in some specific locations of memory, we must have some mechanism to manage all these data in our computer. In order to manage all these data in a well-structured manner, the operating system is going to use a separate type of system-specific data structures. Anyways, I'll explain the data structures used by the operating system in the next and subsequent classes. Now, let me tell you how the user solves the program by writing it and written in high-level language are translated into a low-level language. The high-level language, as you all know that I am speaking English. If these languages are to be understandable to others, it has to be translated by someone else who is familiar with English. So that means there must be a translator who is understanding the English language and translating it to a specific corresponding language. Let me take up one example here. I am the person speaking English here. The intermediary person is very much familiar with English, and the person who is listening to my language may not be familiar with English. He is familiar with Kannada, Telugu, Malayalam or anything. In such cases, the translator is needed. The translator translates the sentences spoken by the speaker into another language. Is done by the translator. The same thing is done by the assembler or a compiler. Whether the programs written in these high-level language like C, C++, Java, .NET, Python or any language programs must be translated into equivalent machine understandable language. Again, what is that machine understandable language? As you all know that a machine understandable language will be in the format of zeros and ones. So we need a translator to convert these high-level languages, technical languages like C, C++, Java into its equivalent zeros and ones. This is called as an engineering, that is translating the languages from high-level language to the machine understandable format is called engineering. And at the same time, translating the low-level language or machine understandable format to the high-level language is called reverse engineering. This engineering is possible, but reverse engineering is not at all possible because it is not in the human readable format. It is highly difficult to understand. It is understandable only to the computer. So we have a translator here which does the task of that. That is called as a system software. Who is that system software? Which is that? Operating system. What is the name of that operating system? Windows operating system, Linux operating system, Android operating system. All these operating systems are responsible for interacting with compilers. If you take up the language C, we have a C compiler or Turbo C compiler. If you take the C++ language, correspondingly we have a Turbo C++ compiler. If you take up the Java compiler. So again, a .NET is a framework. Again, it has its own compiler. Bytecode, it is converted into a bytecode. Then bytecode is in turn converted into a runtime environment suitable format. Similarly, Python language is converted into an interpreter. Who is going to manage all these compilers and all these application specific programs? System software, also called as an operating system. So let me tell you that we have an assembler which breaks up the program down into an assembly code or instruction set and then into a binary machine code. The same thing I spoke right now. That is, the high-level languages like C, C++, Java are converted into a binary equivalent machine understandable format. Then machine code is processed. The machine processes these zeros and ones, binary format data, not the one which is given by the programmer, that is application programmer. So let me take you into the example of that. Here we have a simple C language. Here I have a function called swap. In this I am using a temporary variable called temp. Here I am using the logic which exchanges the values of two variables and returns it to the main function. That is usually done in C language. So the compiler is the one which is responsible for converting these high-level languages into machine understandable format. Right? Then who is going to manage all those compilers? The operating system, also called as a system software. So if this is the case, we have the corresponding assembly level language program here. Assembly level language is also called as a mid-level language program, which is not same as an high-level language program, which is not like the language we use, like goto, break. All these are high-level language, which is very commonly and easily understandable by humans. But it is not like that. We have a word called multi, add, LW, load word, store word, JR. All these are some of the specific words which is written in assembly level language. So that's why we call it as mid-level language. Not even low-level language. It is an intermediary type of language. These are converted into a machine binary code. Now when this you are observing that you are only two types of values. One is 0 and the other one is 1. Now you are not finding anything other than zeros and ones here. These codes are taken by the system and processed. Not this one or this one. So what is that helping me? Which is that software helping me here? Compiler and assembler. For translation purpose. Who is going to manage that compiler and assembler? Operating system, also called as a system software. Even if you open the mobile phones and if you want to open any of the files like Word file or music files or anything from your mobile phone, you can do it so with the help of an operating system called Android, or it may be a Windows-based mobile phones. All those operating systems are responsible for managing the user's request. So let me take you into the next slide wherein you will observe what is a system software. Then a system software is a program that controls and maintains the operations of computers and its devices. Now usually you will see that a CPU is placed on the table and the desktop monitor is also placed there, keyboard, mouse, all these are what? Hardware devices. Once when you plug in the mouse into the CPU, it recognizes the mouse and starts interacting with it. So who is that? Which is that software helping me to recognize the mouse attached to the CPU? Again, it is a system software. If it is a Windows-based operating system, the Windows-based system software operating system is helping me to recognize the mouse. Similarly, if you plug in the keyboard, whether it may be a wireless keyboard or it may be a wired keyboard, these must be recognized by the operating system. Then it is possible to interact between the users and the hardware. It is not at all possible to interact with hardware devices without an operating system. So I can define the operating system as, or a system software as, A system software is a software developed by software programmer, also called system programmer, who does the task of management of these users' requests with the system. Let me make it even more simpler to you. A system software acts as an intermediary between users and hardware. That's all. That is called as a system software. Now, system software serves as an interface between the user and the application software and the computer hardware. The same thing what I explained now is written here. Let me take you to the next slide. I can also define the system software as a bridge between computer hardware and an application software. Suppose if you want to install any of the application softwares like Word or music softwares like Ghana or anything like that, if you install those softwares in your mobile phones, you can make use of that. Who is the one helping it to play? Again, an Android operating system which is servicing the user's request to play those music, to use that Word software, to use that Excel software, to use this PowerPoint software and all those things. So it acts as a bridge between the user and the hardware devices. So next, who is the coordinator here? The coordinator is one who coordinates with hardware as well as a user. So that I was speaking about the translator who was helping me to translate the language from one to another. Similarly, an coordinator is helping me to coordinate with hardware devices. So who is the one responsible here? System software. System software is responsible here. That is operating system. Next, if you look at this device specific architecture, you will see that the relationships among a user and a computer program as well as the system software and application software. I'm using 4 entities here. This is one entity, second entity, third entity, fourth entity. If you look at this diagram, it is bidirectional. That means a user is one who requests the application software. The application software in turn requests the system software, that is operating system, whether it may be Android, Windows or Linux or anything. This system software in turn interacts with CPU hardware devices. Then this data requested by the user is processed in the processing unit. Once it is processed, it is given to the system software. That is, the response is given to the system software related to the question. Suppose if you people may go for an interview, you may be questioned with few specific questions. You must answer the questions relevantly. That means if you are asked to speak about the system software, you must speak only about system software. If you are asked to speak about an assembler, you have to give the details of assembler. That means the questions or the requests requested by the user is processed by the processing unit called the CPU. Once it is processed, it is given to the system software. That is, the response is given to the system software. Once the response is given, it has to be serviced to the application software once again. This in turn gives the response to user. So, by looking at this diagram, you will see that there is no direct interaction between an hardware and the user. So, which is the software lies intermediary between user and the hardware? The system software. This system software is mainly responsible for interacting with hardware devices as well as with software services, or also called as system as a service. System as a service. And of course, you will see that software as a service. I will call it as a system as a service. Why? In the software engineering, you will see that. Here, which is the software helping me to interact with hardware devices? System software. The person who or the programmer who develops this system software are called as system programmer, and the developer who develops the application software are called as application programmer. So there is a difference between an application programmer as well as system programmer. Suppose if you want to develop any of the softwares for railway reservation management system, that is again an application software that is developed by any companies. Suppose if you take up the ATM machines, which is incorporated with certain specific operating systems as well as softwares. Again, that is an application software incorporated with a system software which is developed by Infosys. So we have all these types of application software. And there are various types of people who does the task of application software, similarly who does the task of system programming. If you look at this slide, you will see that the terminologies, which is the terminology that helps me to distinguish it from one to another. Firmware. What is the meaning of firmware? A firmware is again a system software that is incorporated with the hardware. As I have already told you, a loader. You will come across this loader next. The combination of software and a hardware together forms a firmware, which may be a ROM. As I told you at the beginning of this session, a ROM is incorporated or inbuilt with loaders. These loaders are responsible for loading the operating systems onto the main memory when you click on the power button. So the firmware is a combination of hardware and software. I can say that. ROM, read-only memory. PROM, programmable read-only memory. EPROM, electrically erasable programmable read-only memory. All these are different types of firmwares present in your computers. Next, assembler. As I have already discussed with you, an assembler is one also called as a translator who translates the high-level language or the intermediary language to the machine understandable format. Next, loader. Loader is already known to you with this discussion. That is, the loader is again a system software that is loaders are responsible for loading the operating system from firmware to the main memory. Next, linker. During the execution of programs, suppose you have a main function at the bottom of the program. At the beginning, you have few definitions, function definitions. That is function definition 1. Function definition 2. At the bottom of your program, you have a main function. And of course, compilation always begins from the first line of the source code, and the execution always begins from the main program. So, who is the one responsible for invoking all these functions? You need a linker. A linker is one that helps you to link the function declaration with function definitions and return the values returned by the function definitions into the main function. Again, the second function is linked with the main function is done by the linker. Again, the returned value is saved into the main function. So the interlinking between the main function and the function modules are done by the linker. In the object program, that is in the machine understandable format. So next, operating system. As you all know that it is a system software that manages every other hardware devices and serves the requests of the user. Similarly, a compiler. A compiler is again a system software that checks the syntax used by the programmer and allows further to run the program for the successful execution of application software. Next, an application software versus system software. Here you are observing the differences between application software and system software. It emphasizes on solving problems and uses the computers as tools in case of application softwares. In case of system softwares, it serves the requests of users as well as the hardware devices. The second difference between application software and the system software. Application softwares includes data structures like doubly linked lists, single linked lists, stacks, queues. All these are different types of data structures. You can insert the data into any location using the insert command or insert function, then delete the value from that location. And all those things can be done in the application software level. Whereas in case of system software, it manages the resources. What is the meaning of resource here? Process, memory management, all those things are managed by the operating system. Application software is going to manage the data. System software is going to manage the resources. So there must be a coordination between the application software and the system software. Whatever the data you enter into the system, that has to be saved in some particular location. Who is going to save it in particular location in a well-organized manner? Application software. Who is going to serve the request of the users or the application software? System software. System software is going to provide a service to the application software. So again, there is a coordination between an application software and the system software. Next, provide services to end users. As I have already told you in the previous picture, that is, the user's requests are serviced by the application software. Then, between application software and the hardware, which interface or a bridge lies? System software. So, provide services to application software and the programmer. Then, normally written in high-level language. We know that these programs can be written in high-level languages like C, C++, Java, and many other languages. But these are normally written in C language. Next, it is used only when the application purpose is required. This is used when you turn on the computer. As I have already told you that when you turn on the computer or when you press the power button, automatically the loader starts working on it and then the operating system starts working. Then it performs only single task. It has to perform multiple tasks. That is, it also needs to manage memory. It also needs to manage process, and many other tasks are to be carried out by the operating system. So the application software is related to only one single task and system software is related to multitasking. Then the program normally works one process at one time and step by step. Here, normally it controls many processes at the same time. Multitasking, multi-processes, dual core processors. quad-core processors. What is that? All these are processors which are capable enough in handling multiple tasks. Whereas the application software, it is capable of handling only one task at a time. That is the difference between an application software and the system software. To explain these subjects, I am using Leland L. Beck as a reference book to refer these topics what I discussed right now. Kindly go through this reference book, and if you come across any questions, kindly update me in this. Thank you very much. Thank you to all.